As an annuity is a series of payments or receipts, so like its future value, we can also calculate its present value. And the important thing is that by using a formula, which is the formula of present value of an annuity, we can calculate its present value in one go. Otherwise, to calculate the present value, we have to discount every individual amount in that series. यानी अगर हमारे पास 50 या 100 मुख्तलिफ इंस्टॉलमेंट्स हैं तो हमें हर एक को इंडिविजुअली डिस्काउंट करना होगा अगर हम प्रेजेंट वैल्यू ऑफ एनिटी का फॉर्मूला इस्तेमाल ना करें. Let's have a look at this formula. This is the formula which is shown on your screen is the present value of an ordinary annuity formula. Have a look at the contents of this formula. Here PV stands for the present value of annuity, and when we use the term present value of annuity, we means ordinary annuity or deferred annuity. We have discussed it that ordinary annuity or deferred annuity is one in which the payments or receipts are at the end of the period. In this formula, we have capital R, which is a symbol of amount of installment, that is, the series of payments. And then we have small r, which is the rate of interest. When we are calculating the present value, this rate of interest is called the discounting rate, and n is the number of installments. Here I would like to mention it that n should not be considered as the discounting period, for the reason that in some cases we apply the formula annually and we have got more installments in 1 year. For example, if the installments are monthly or quarterly, then in 1 year we'll have more number of installments. So a better way is to consider n as the number of installments in that particular problem. Now, let's try to understand this with the help of an example. If rupees 3,000 are paid at the end of every year for 7 years, what will be the present value of this annuity given that 8% interest per annum is paid? Now, to calculate the present value, we need to know the amount of installment which is there, that is 3,000. We also need to know how many installments are there, which is 7, and we also need to have the interest rate or discounting rate, which is 8%. So we have got all the ingredients, and when we apply the formula that we have just seen, this is how we get the present value. So 3,000 is then multiplied by the answer of this interest factor, annuities interest present value interest factor, which is 5.206, and ultimately we get the total present value of 15,618. If we have a look at this solution, we see that in one go, in one attempt, that is by applying the formula only once, we have got the present value of all the installments. We did not have to apply the present value formula 7 times and sum up the values of those 7 answers to get the present value of the annuity, but formula has given us the present value in one go. Now let's have a look at this part of the formula, which is called the present value interest factor of an annuity. If you remember, in our earlier lectures, we have talked about the present value interest factor, PVIF, which is the present value factor for one single amount that is there somewhere in the future. यानी अगर हमारे पास फ्यूचर में एक सिंगल अमाउंट हो तो उसकी प्रेजेंट वैल्यू निकालने के लिए जो फैक्टर हम यूज़ करते हैं उसे प्रेजेंट वैल्यू इंटरेस्ट फैक्टर कहा जाता है. लेकिन अगर हमारे पास सीरीज ऑफ पेमेंट्स और रिसीट्स हो, यानी अगर हमारे पास एक एन्युटी हो तो NAT की प्रेजेंट वैल्यू निकालने के लिए जो फॉर्मूला हम यूज़ करते हैं, उसके अंदर जो फैक्टर इस्तेमाल किया जाता है उसको प्रेजेंट वैल्यू इंटरेस्ट फैक्टर ऑफ एन NAT कहा जाता है। यानी ये फैक्टर जो आपको स्क्रीन पर नज़र आ रहा है, 1 - 1 + r रेज टू द पावर -n डिवाइडेड बाय r। यहाँ पर r वही इंटरेस्ट रेट है और n नंबर ऑफ इंस्टॉलमेंट्स हैं। अगर आप इस फॉर्मूले में देखें तो n जो है वो नेगेटिव है, यानी नेगेटिव वैल्यू n ये शो कर रही है कि हमें इसको 1 से डिवाइड करना है, यानी 1 - 1/1 + r रेज टू द पावर n।